Do you remember sorting numbers? Welcome back, by the way. So sorting numbers has to do with arranging numbers in ascending order and descending order, and just making sure you know who's bigger than who. And we don't really venture into this too much. I just want to mention it as a topic so you know it's here, because you should know that 7 is bigger than 5. And there are symbols that we can use for this. We usually use symbols like these, or to assign numbers based off of their size, right? So which one of these symbols do you expect to go here? Yes, we will put this one, because we're trying to show that 5 is less than 7, or if we read it this way, the 7 is facing the open side, 7 is more than 5. Yeah? So yeah, so I hope everybody's saying yes behind the screen there. What about if I said 101, 1001, 25, 256, and I said to arrange in ascending order? Ascending means what? Ascending means coming down. No, of course. Ascending means going up. Like you're going up the stairs, you're ascending. So ascending means start at the lowest and go to the top. So I would look for the smallest number, which is easily spotted as 25. Then, of course, 101. Then 256. Then 1001. This is in ascending order. But who determines that these numbers are bigger? Well, you have to tell me that these numbers are bigger. And there are some clues. Which digit in a number has the most value? Here's a question that I asked my Form 5 students. These are students that are 15 years old. I want to tell you that the bank, the student hub bank, all right, and in this bank, you have some money. The bank is saying that watch this, I'm going to give you a lot of money here. Let's see how much money you have here. 1,090,000, let's say $96,587. Which one of these numbers is the most important number to you? Which one of these numbers have the most value? Or if the student hub bank, HSH bank, rings your phone and say, hey, your bank account was $1,096,587, but something happened and one of the numbers went missing. Which number do you want that to be to go missing? You are hoping that the 7 goes missing. That's just $7. Okay, let the 7 be turned to 0 or something, right? But you know what is 1 to go missing? That 1 is the most valuable number there. That stands for 1 million. So the numbers that are further this way, or to the left of the number where you are watching it, to the left of the number, have the most value. So that's a clue for arranging numbers in ascending or descending order. Because you could be like, okay, this is 25. This 2 has a value of 2 tens, but this 1 has a value of 100, so it's bigger than 2 tens. This has a value of 200, so it's bigger. Although this doesn't have 200 or any tens, it has a value of 1,000 over there, so we know that's the biggest number. New question. What is the most important number in approximation? Okay. So we know 9 is an important number. 9 is really high, it's close, but I don't think that's the most important number in approximation. And you know what approximation means? Rounding off. Approximation, rounding off. Similar things we're talking about here. Camera guy, what do you think is the most important number in approximation? 5. Yes, he got it. So 5 is the most important number in approximation. But why is 5 the most important number in approximation? All right, so what type of approximation do you know? You know place value approximation. Like if I gave you the number 346 and I said approximate to the nearest 10, what are you supposed to do? You're supposed to underline the 10, watch the number that comes after the place value you're interested in. If it's 5 or more, you give him the boost and you change all the other numbers to 0. So we have 350 to the nearest 10. And there are some tricks that can come with this. We'll go over them in the live class. You should be aware of this. You should know this. This is from previous levels of mathematics. But we still want to refresh everything, right? But why is 5 the most important number? Because it's like the middle point. It's like the decision line. For example, if we had 152, and I want you to approximate this to the nearest 100. So you're supposed to underline the hundreds. Watch the number that comes after. It's a 5. So 5 is still on the middle line. It's still on the cutoff point. It's still going to assign upwards. We still have to round up. We still have to give the place value we are interested in a boost. So we give that a +1. This becomes 200. And what happens to the other numbers? They change to 0. And then we write equal to 200 and we say what approximation we use. To the nearest 100. So I want to revisit this approximation at a later date or in the live classes and give you some assignments and make sure that everyone is on board with this. Thumbs up if you got it. Let's go on to the next style of approximation. Whole number approximation. This is really place value approximation in a special way. The place value that we are looking at is the ones column. So whole number approximation is approximating to the nearest ones basically. Let me show you. So if you have a decimal number, 15.278, and I said approximate this to the nearest whole number. What do we do? Well, you underline the whole number, just like the ones column, you underline that. You look at the number that comes afterwards. What is that number? It's a 2. It's not 5 or more. No boost for this place value, that whole number column. So the answer is just 15.000. Since all the others turn 0, it's 15, which is a whole number, which is why we call it whole number approximation. And let's not make this class go too long. Decimal place approximation is the last thing that we are going to do. Decimal place approximation, we say the decimal place that we are interested in. Let me show you. There's a number 0.4538. If I told you to round this off, listen to my words. Listen. Round this off to 2 decimal places. What should you do? Well, go find the second decimal place, my friend. Run along now. Underline the second decimal place. Direct your eyes to the place after it. It's a 3. So do we boost? No, we don't boost. All approximation have this similar idea. We don't give it that one boost. So it is a 4, 5. This is 0, 0. Or we can just say 0.45. And we write the approximation that we use. That's the only way we are allowed to use an equal sign here. 2 decimal places. What do you see sometimes instead of writing out decimal places? Sometimes you may see mathematicians use DP to 2DP, which stands for decimal places. One more and we'll close up class. One more. All right, 45.13951, 13591, and that's the number we're going to approximate. Wait, you can't approximate anything yet. I didn't tell you how much decimal places. I'm not going to tell you. 1, 2, 3. 3 decimal places. Can you approximate that number to 3 decimal places? First thing, you run along now with top speed and you're looking at the 3rd decimal place. You can approximate, you underline that. Then you look at the number that comes afterwards. Let me draw my eyes to signify that I'm watching you. 5, I'm watching you. And wait, it's 5, so we have to boost. So we give this a boost and that 9 becomes 10. So can we just write 45.1310? Of course not. 10, we cannot fit 2 digits in one numeral place value. So what do we do? Well, we make a 0 here, and the 1 travels along and now adds to the 3. So if I add 1 to this 3, it becomes 4, because 1 plus 3, if you take a time and we're it's going to be 4. So 45.140. Don't forget to put equal, and don't forget to put what you approximated to 3 decimal places. I'll see you in the next session, folks. Love and blessings.